Here we're running an app locally that's serving a WebAssembly binary of LND. Here we're running a local LND that's keeping up with the graph. We're going to kill that. And one that's running neutrino that's keeping up with the chain. We're going to kill that. And then we're going to mash them up and convert the VoltDB databases to LevelDB. Zip it all up for serving along with that LND binary to a browser. Now we're gonna start that LND back up because we're gonna need it in a few minutes. It's connecting to more peers, getting caught back up with the graph. Okay, let's start Chrome. And so now we're gonna clear all the data so that we're starting fresh. Now we're gonna start the app. And it's going to ask us to store files in our browser's HTML5 file system, which is currently empty. So we're going to allow it, and it's going to load up an LND data directory structure with the channel DB and all of the neutrino data. This is pretty cutting edge tech, bleeding edge tech. Including some of the things we rely on, like Go's WebAssembly support. So lots of things aren't working yet. Preload complete. Let's take a look at what's in here. We should have an LND directory structure with an empty lnd.conf. So there it is. And then under data, we'll have the graph data, which is just the channel DB in LevelDB format. And then we have the chain data, which is the neutrino data, the filter headers, the block headers, and a filtered DB that's also in LevelDB format. And now we can start LND. It generates TLS certificates, so we can see those in our file system now. We're not really doing anything with macaroons yet. In order to connect to the LND node's RPC, we are connecting over a message channel instead of over TCP. So you can see that transport override with a message channel as we initialize a wallet. Now we're going to wait for the wallet unlocker to close, and in the meantime, we'll find a peer. We've got 3 peers connected, so let's find their pub keys, and let's see which one of those has some channels through which we might be able to pay. This first one has 13 channels. The next one has 1 channel, and then the last one has 10 channels. So let's go back to the one that's got 13 channels, and we'll connect to that one from our web browser LND. So there's its address. We're going to run a WebSocket proxy here locally because our outbound connections are using WebSockets for both Bitcoin PTP and LND or Lightning peer-to-peer. So here we go. We're going to copy the key so that we can paste it into the browser. We've got the WebSocket proxy listening on localhost on port 80, and as you can see, it's already in a peer address. We paste the peer key and connect to the peer, and there we go. We're caught up to the graph, or should be. Get info, sync to graph true, sync to chain true. Our preload worked. Let's see. Our local node is also synced. We've got some wallet balance. Let's generate an address and we'll give some money to this node running in the browser. We'll send about 100,000 sats, and we're doing this as Bitcoin is going up and right before the US election, so we're gonna spend some money on fees today. This is pretty reckless. There's our transaction. It's been broadcast, but Neutrino isn't going to see it until it's been confirmed, because it uses the compact filters to check whether a transaction is in a block. It doesn't listen for mempool transactions because it can't verify them. So let's see. It shouldn't see any transactions yet. There we go, none. It should not see any wallet balance yet, even unconfirmed. There we go, no unconfirmed balance either. Now we need to wait for a block. So again, just as a review, to connect to the RPC port of LND, we're using message channels, JavaScript message channels. Oh, here we go, we have a block. And then this is all running in the UI thread, so it blocks the UI when it's busy. So now that we have a block, we can check the wallet balance, but it's not fully done processing that block. So as you can see, we push the wallet balance button, and there's a little bit of a delay while LND is busy before it gives up control to the UI thread. So here we go. We've actually sent the request. Now we've got a response, and we have a confirmed balance of 100,000 sats. We have a transaction where we are the recipient of one of the outputs. Yay. Okay. Now we can create a channel to our peer. Let's try 70K sats. We're also doing 300 sats per byte on this. Nope, we need more. It's too much fees. So let's cut this down to 50K sats for the channel capacity. Let's open that channel, and here we go. We've got a channel funding transaction. So the channel backup is not working yet because it's not serializing the WebSocket connections, as you can see from this error message. Yeah, this error message right here at the bottom. So now we need to wait for 3 blocks for this to confirm. As you can see, we've got a pending channel and no active channels. So we're going to wait for 3 blocks. Yeah, so we use message channels to talk to RPC. We use WebSockets to connect outbound to the Bitcoin peer-to-peer network and to the Lightning network. And we have WebSockify proxying those WebSocket connections. Chrome does support TCP connections directly, I think, but we want to stay compatible with Firefox eventually as well. So we're focusing on WebSocket connectivity for outbound and still message channel connectivity for RPC from the JavaScript code to LND. So now we're waiting for some blocks. We've had a couple blocks here. We fast forwarded a little bit through a couple blocks. So now we're just waiting for our third block, and then it should be a fully active channel. Again, this stuff is pretty bleeding edge. Lots of stuff isn't working yet. The tools we're using, like Go, are still considering WebAssembly support experimental. So this is very much a work in progress and kind of a R&D project at this point. There's a lot of work to be done to make it more reliable and to make everything work. So here we go. Here's our third block. We've got an active channel. So now when we check pending channels, we shouldn't have any. And when we check active channels, we should have one. Let's do that. Oh, and here we go. We've got the error message because the channel backup can't encode the WebSocket address yet. So no pending channels. One active channel. Yay. Okay, now we're going to open up Moneni, which is a custodial Lightning wallet. We've got it open in Firefox with a 0 balance, I believe. There we go. Yep. Recheck balance. It's still 0. Now let's generate an invoice for 1,000 sats. And we're going to copy this invoice. We've got 1,000 sats pending inbound because we're waiting on this invoice. We're going to paste the invoice and pay it. And again, this is pretty slow because it's running inside the browser in WebAssembly, but now it should be looking for a path for this payment. This is exciting. This is the first time we've had a, oh, interesting warning. This is the first successful channel we've been able to open on mainnet. Some interesting warnings as we search through the graph. Not everything is working yet. It should be enough for a demo. Timeout error, another warning. Lots of interesting bugs to fix. And it looks like we've got the pre-image, and we went through maybe 3 hops to make this payment. Let's look over at Moneni, recheck our balance. Here we go, we've got 1,000 Satoshis in our wallet. Yay, that's the first successful mainnet Lightning payment from a node running inside a browser, as far as I'm aware. I'm pretty sure at least LND running inside a browser in WebAssembly.